Welcome to Tech Teach.
In the previous class, we have gone through flow and error control protocols. So in that, two different types are there: noiseless for noiseless channel and for noisy channel. For noiseless channel, we have the simple and stop and wait protocols. That is the case when there is like no error is possible, because this is an ideal channel is there. So no package drop or frame drop or acknowledgement loss will be there. But the practical channels will be like, that will be called the noisy channels, that will be having the probability of errors. So for that, there are three different protocols defined. So first one is stop and wait ARQ. This stop and wait ARQ is basically, you will be sending the frame and then waiting for the acknowledgement. Along with the waiting for acknowledgement, it will be having a timer. Either the acknowledgement is received, then the next frame will be sent, or the timer is timeout, then the same frame will be sent that is already sent. Whose acknowledgement is not received. So this is the basic idea about stop and wait ARQ. The next we will be looking at is the sliding window protocol. So under sliding window protocol, we are having go back and ARQ and selective repeat ARQ. So these two are the protocols that are basically going to remove the disadvantage or limitation of stop and wait ARQ. So in stop and wait ARQ, we are having the limitation like it can send only one packet at a time. But in case of these two protocols here, instead of sending single frames, we will be able to send more than one frame. So we will be looking at these two one by one. Next, we will be looking at like then the first category of sliding window, that is go back and protocol. So in go back and protocol, here it is, and this n is basically going to tell us like the window size. So in case of sliding window protocol, we have fixed window size. But in case of go back and type of protocol, here the size of the window will be depending on the n value. Okay, and here also this n will be decided based on like the number of bits that are available into the headers. And here the m is basically the size of the sequence number filled in the bits. Like whatever the sequence number is there that is being generated, for generating sequence number, what is the number of bits available, because this sequence number will be available in the header that is there. So in data link layer, because these are the part of data link layer itself. So in data link layer, basically while doing the framing, we add headers and trailers. So whatever the header and trailers are there, so whatever amount of bits available into headers, based on that, some bits are reserved for sequence number field. Okay, so that's sequence number for the frame number, sequence number. Okay, so whatever, suppose m number of bits are there for sequence number, then this capital N, that is what number of sequences all possible will be to the power m. So based on to the power m, this modulo to the power m. So suppose m is equals to 2. In that case, 2 to the power 2 or 2 to the power m will be 2 to the power 2, that is 4. That means here modulo 4 in the meaning is like here 4 numbers will be there starting with 0, 1, 2, 3, or each will be used for 2 bits. So 0, 0, 0, 1, 1, 0, 1, 1. This will be the one. So modulo 4. So here n will be the 4. So it will be behaving like go back n protocol. Okay, so go back 4 protocol likewise. So this is the basic idea in go back n protocol. So what is the basic difference? We will just see. So before that, here it is showing like what is the send window. So there in sending up frames, we are having a sender and we are having a receiver. So at the sender side, what will be the structure of the window that is shown here? So it is considered for m is equals to 4. So if m is equals to 4, then 2 to the power 4 will be like 16. So 16 sequence numbers will be there. So starting with 0, 0, 0, 0 to maximum 1, 1, 1, 1. So that is 0 and maximum is 15. So starting with 0 to 15 will be the total number of sequence numbers of the frames that are available. Okay, so whatever the frames are there, so the window size here, so that is n. So to the power 4, that will be equals to n. So this n will be there. That means the window size will be n. But here we will just let you know, like, the maximum window size can be the n, that is 16. But generally it is considered like n minus 1 as the window size. Okay, so that's why instead of 0 to 15, it is 0 to 14 is the window size. So out of that, so it will be considered like the size of the window will be like 2 to the power m minus 1, 1 less than. Okay, so this will be the window size. Basically, we can represent it like 2 to the power m minus 1. Okay, so this will be the size of the window. So into the size of the window, how it will look like. So suppose this is the window size starting with here to here. So this is the window size. So into that window size, S stand for sender side. This here S also stand for sender side, send window. Okay. SF is the one. F SF indicate the first frame that is to be sent. Okay. So this is the first frame that is SF is the first frame that is sent, and its acknowledgement is being wait. So this red color indicates like these frames have been sent, but its acknowledgement have not received. So it is like frames sent but not acknowledged. So this will be red in color. This white color indicate like from here onwards, the next, this is going to say like next frame that needs to be sent. Okay, that means these frames are available at the data link layer, but they have not been sent yet. They need to be sent after acknowledgement received for these. Okay, and this is indicating like frames that cannot be sent because it has not been received from the upper layer. Okay, that is not part of the window, so it will not be sent. So that only be sent. So frames only be sent. That is part of the window size. So here frames that can be sent but not received from the upper layer. That is this one white one. This is frames sent not acknowledged. These are the red color that are the one that is sent, but they have not been acknowledged. And these 13, 14, 15. So this is prior to that. This window size, the sequence will be starting with 0, 0, 0 to 15. So after 15, there will be again 0 to 15. Then again after 15, 0 to 15 likewise. The sequence of different frames will be done. So here 13, 14, 15, that is crossed. Okay, that means these have been sent and its acknowledgement have been received. So already frames already acknowledged, sent and unacknowledged. So that will be the one that is the send window before sliding. So before sliding, this will be there. So once suppose some acknowledgement have received. So send window after sliding. Sliding in the sense some acknowledgement will be received, then the sliding will be done. So once the acknowledgement is received, suppose for 0, 1, 2, this window size will be slided. So windows will be slided. So 1, 2, 3 frames will be considered. So 1, 2, 3 will be part of the frame now. So this is how the basically sliding is takes place. So we have already seen in this example also. So how the sliding takes place. So similar is given in terms of generalized format. So here the send window is an abstract concept defining an imaginary box of size to the power m minus 1. So in that the box size is considered as imaginary one, which is not like that is just for showing. So for basic understanding, this box type structure is shown, but it is an imaginary one. But it is like they will be considering to the power m minus 1 as the size or length of the box will be there with three variables. So these three variables will be defining the SF, SN, and S size. So S size, SN, and SF and SN will be the one that will be defining the different parameters of the window. The send window can slide one or more slots when valid acknowledgement is arrived. So whenever the valid acknowledgement is received, then the sliding will be done. The sliding can be done for more than one slot also. One slot in the sense, sometimes what happens, the acknowledgement that is received, a single acknowledgement can be received for different frames also. So that's why at a time more than one slots can be slided by the window. So this is going to see like what is the receiver window, how it look like at the receiver end. So at the receiver end, in case of go back and protocol. So here at the receiver end, the window size is always of one frame. That means it should be waiting for this. If it is indicating likewise, it means received window. R stands for received window, N stands for next frame expected. That means up to 210 these frames have been received, or these frames have been received and acknowledged. These frames have been received and acknowledged, and this is the one that is next frame expecting. So the receiver is expecting the frame number 3, and these are like frames that cannot be received until window slides. So when it is received, this window will be sliding. So this is receive window, and this is receive window after sliding. So suppose 3 is received and it is acknowledged, then this window will be sliding to this position, that is by 1 frame. So at the receiver side, the window size is of 1 frame, but at the sender side, the size is 2 to the power m minus 1. So the same point is written here. The receive window is an abstract concept defining an imaginary box of size 1. So size will be 1 with one single variable Rn. The window slides when a correct frame has arrived. Sliding occurs one slot at a time. So one slot at a time it will be taking sliding, and once correct frame is, because it is expecting 3 frame number 3, if 3 frame number is arrived, then the window will be sliding. So we will just take the example. Okay, suppose we are having a sender and we are having a receiver. Okay, so we are having a sender and we are having a receiver, and we are going to have, suppose some set of frames will be there. Okay, so set of frames are there. Frames are suppose 0, 1, 2, 2, 3, 4, 5, 6, 7, 8. So it can be numbered from any direction. Okay, so that is a basic understanding how we can understand the frames. So this is there. So suppose the frame size or the window size is basically 4. If suppose the window size is 4. Okay, so if the window size is 4, it will be considering this at first the window, then the 4 frames will be sent 0, 1, 2, and 3. So this will be sent. Okay, so this is the case for the first, like if window size is 4, 4 frames will be sent. So once it is sent, its acknowledgement is received. So suppose for the 0th one, the acknowledgement is received. Then if the acknowledgement is received, then it will be slided. So this will be slided to next one. So next one, if it is sliding to next one, means 4 will be sent now. So from here, the 4 will be sent once the acknowledgement is received. Then suppose one acknowledgement for 1 is received, frame number 1, then it will be like sending the next. So its sliding window will be coming to here now. So once it is likewise, it will be sent. Suppose the frame number 2 that is coming, but it is not received. If the frame number 2 is not received, if it is not received, it will be waiting for a certain amount of time. So here also the timer is there. So if the frame number 2 is not received, it will be keep on waiting for certain amount of time. Suppose the time expires. So after sending, suppose up to here, so up to here to 4, suppose time expires here, timeout is there. So at this point, the timeout is there and the acknowledgement for 2 is not received. So if the acknowledgement of 2 is not received, then whatever is the window, so this is the last window that was there. So 2, 3, 4, 5. So at this time, if the acknowledgement is not received and timeout is there, then the sender will again send all the frames that are available into the last window. So last window is having 2, 3, 4, 5. So it will again send the 2, 3, 4, and 5. 2, 3, 4, and 5. It will be sending 2, 3, 4, 5 again. And then after sending, it will be the timer will be starting and it will be waiting for the acknowledgement. If suppose the acknowledgement for 2 is received, acknowledgement of 2 is received, then the window size now will be from 3 to 6. So 6 will be sent here. So this is the basic idea. So what is what we can conclude, first of all, it will be more than one frames are sent. Okay, and there will be a timer, first of all. Also, so there will be a timer that will be noting out the timer. Okay, so based on that, it will be deciding. So if more than one frames are being sent, it is going to have better performance because more channel utilization will be there. Utilization will be higher in case of go back and ARQ. And here also, if one more like one point that is disadvantage, we can call it here, or limitation. If any acknowledgement is missed, then it will be sending all the frames available into the window. Resend all frames available in the window. So at that time, in the window, whatever the number of frames are there, they will be resent till the acknowledgement is not received. So till the turnaround time, if the timeout time, if there is acknowledgement not received, all the frames will be sent again, and then it will keep on waiting for the acknowledgement. If the acknowledgement is received, then the next frame will be sent. So this is the basic disadvantage of the go back and ARQ. So we will just see some more things. This is the basic idea. Then we will be going with the design. So how the design is there. So design is the same thing. So here this part will be like, once there is a request from the network layer, the request is there, then it will be getting the data, then framing it, then send the frame. Once it will be sending the frame, so 1 frame, 2 frame, 3 frame, it will be sending number of frames based on the size of the n value. Okay, so it is sending. So after sending, the physical layer will be acknowledging is the arrival, then it will be notifying the data link layer of the receiver. It will be receiving the frames, then it will be delivering to the network layer, then it will be sending the frame acknowledgement. So for each one, the frame acknowledgement will be sent with the sequence number and acknowledgement number. So here also, so sequence number, frame, and acknowledgement sequence number is there. So these points you can note it down. Okay, so this is the basic idea, and then acknowledgement is sent, so it will be notifying to the data link layer. So this data link layer, once the acknowledgement is received, it will be sending the next frame. So this is the basic idea. Okay, so but one thing is, instead of sending single frame, it is sending more than one frame at a time. So this is the basic idea into the go back n. So when there will be go back n, so why it is called go back n? Because if suppose 2 is not received, then again at this point it is going back to this frame number 2, because 2 is not received till the timeout is there. So it will be going to go back to, so go back to whatever at this frame number, it will be going to the frame number that where that acknowledgement is not received. So that's why it is called like go back n protocol. So this is the basic idea. Okay, so one point that is basically need to be considered here is always it is considered to take like the window size should be less than 2 to the power m. Okay, so instead of considering like 2 to the power m minus 1, so that is less than 2 to the power m. So why 2 to the power m minus 1 is considered? So like, yeah, so like suppose here in the example that we have considered, so suppose we have taken window size as 4. Okay, so if we have taken the window size 4, it's like if 2-bit was there, so m is equals to 2, then 2 to the power 2 that we have directly taken 4. Okay, so there's can be some error. So what can be the error? So why it is always taken like 2 to the power m minus 1 is taken? So why it is taken? There is an example given. So suppose there is a window size that is having 2 to the power m, window size that is less than 2 to the power m. So that means suppose m here is 2. So if m here is 2, that means 2 to the power 2 means 4. So window size 2 to the power 2 is 4. So window size is taken here less than 2 to the power 2. That means here the window size is taken 3, 1, 2, 3 frames, not the 4. Okay, so here the window size is 4 minus 1, that is 3. So 3 is there. So what is the advantage of taking 3 and what is the disadvantage of taking 4? And that is given here. So once there is a sender and receiver. So if suppose it is saying like whenever the packet is the frame is sent, acknowledgement always is missed. That means acknowledgement is not reaching to the sender. So suppose 3 window frame is there. So 0, 1, 2. So 0, 1, 2. So this will be the one that is being sent. So it is sent. Then its acknowledgement is waiting for acknowledgement. That means that's why it is red. So it is send, and here receiver was waiting for frame number 0. So frame number 0 was received. Then it will be sending an acknowledgement. After sending the acknowledgement, it will be waiting for frame number 1. So this is at this stage, it will be waiting for frame number 1. After sending frame 0, it is going to send frame number 1 and then frame number 2. So because window size is 3, so 1, 2, 3. So one frame, then second frame, and third frame is sent. So while the sending, there will be timer. Timer starts, and this is the time at which the timeout will be there. So by this time, at least the acknowledgement of frame number 0 should have received. But till this time, there is no acknowledgement received. So if there is no acknowledgement is received, then what this sender will be doing is again sending the frame number 0, 1, and 2. Because no acknowledgement is received till then, timeout is there. So it will be sending the frame number 0 and then frame number 1 and frame number 2 likewise. But just see that at the receiver end. So receiver end, it was waiting for frame number acknowledgement to send the acknowledgement number 0. Now it has sent the acknowledgement number 0. Now it is waiting for, because it is receiving the frames. Frames are receiving, but acknowledgement is not reaching to the sender. So it is able to receive the frame number 1, then it will be sending the acknowledgement for frame number 1. Next, this time it is waiting for frame number 2 and it has received, then it will be sending the acknowledgement. Okay, so this is the acknowledgement for 0, this is acknowledgement for 1, this is acknowledgement for 2. And after that, because the receiver knows like I have received the frames and I have sent the acknowledgement. Receiver doesn't know whether the acknowledgement has reached to the sender or not. So next time it will be waiting for the frame number 3 to arrive. Okay, so it will be waiting for 3 to arrive and then send in the acknowledgement. But here the frame number 0 came. So if the frame number 0 came, but it was waiting for 3, that means because it is waiting for 3, but it is 0 is coming, so it will be discarding. So it is like correctly discarding because it has already sent the acknowledgements, and next frame that is it will be waiting for is 3, but frame number 0 is coming because acknowledgement has not received. So this is the correct way. Okay, so correct way to discard. But suppose we are having the window size is stood for m, that is window size is 4. If m is equals to 2, in that case window size is 4, so 0, 1, 2, 3 will be the window size, 4 frames. Frame number 0 is sent, again no acknowledgement is reaching to the sender, suppose. So frame number 0, it is waiting for frame number 0, it is received, then acknowledgement is saved. Then frame number 2, frame 1, 2, 3, 4, 3, up to 3 the frames will be sent. So after that, after sending this, by this time the acknowledgement should have received, but acknowledgement not received. Okay, then if the acknowledgement is not received, then the sender, what it will do is it will again send frame number 0, 1, and 2, and 3. It will send the frames again. But in terms of receiver, and you can just see it is waiting for frame number 2, then received, then acknowledgement sent, 3 sent. Then after 3, next is it is waiting for 0. This 0 is for the next window. This is window 1, this is the window 2, because this is the 0 that is for the window 2. Because if these are the frames, so numbering will be 1, 0, 1, 2, 3. After that 0, 1, 2, 3. So this is for the window 1, numbering for window 1. This is numbering for window 2. So this 2, this 0 is basically for the window 2. Okay, but as the acknowledgement has not received by the sender, so it is sending the 0 frame of the first window itself. So here there is a acceptance because it is waiting for 0 and 0 is received. Then it will be sending an acknowledgement, but this acknowledgement is from the window 2. So there is an erroneously acceptance will be there. So that's why it is preferred to consider like window size should be less than 2 to the power m, or that's why the window size is considered 2 to the power m minus 1 in case of go back n. So here that's why the point is here written go back n ARQ, the size of the window must be less than 2 to the power m. So the size of receiver window is always 1. So this is the point in case of go back and ARQ. This is the algorithm. You can go through it. Okay. So here an example is given. Same example is being considered here. Okay. So similar to that, here is the size like here n sorry m is 3 bit. So if m is 3 bit, so to the power 3 is coming out to be the 8. So if it is 8, so it will not be taken as the size of window will not be 8. It will be less than 8. So that's why it is taken less than 1 means 2 to the power 3 minus 1, that is 7. So 0, 1, 2, 3, 4, 5, 6. Up to 6 means 0 to 6 means 7. So 7 is the size. So at the initial stage, initially, okay. So SF means the first frame that needs to be sent, and SN is the next frame that is to be sent. So this is at this point. Both are pointing at this point. And here RN, that is the receiver is waiting for 0 frame. Okay, and then it will be sending the acknowledgement. So once there is a request, this is the when it will be initially waiting. When there is a request from the network layer, then it will be sending this. So it will be sending the frame number 0. Okay, and it was waiting for frame number 0. So once it was waiting for frame number 0, it has received the frame number 0. Then it will be sending the acknowledgement. Okay, acknowledgement 1. It will be sending the acknowledgement 1. That is like it was waiting for 0 and 0 has received the, so it is sending the acknowledgement 1. Okay, so next here is there, and here the acknowledgement is received. So when acknowledgement is received, there is a sliding in the window. So this window is sliding. It was initially up to 6, now it is up to 7. So now at this point, arrival time, SF and SN will be same. Then when there is a request from the network layer, then frame number 1 will be sent. Frame number 1 is sent, and at that time it was waiting for the frame number 1. So it has received the frame number 1 and it has sent the acknowledgement. So if the acknowledgement is sent, but it is failed, acknowledgement is not received. Okay, so because the window size here is 7, so it will be keep on timer starts up to 7. Up to 7 sent, it will wait, and then after there will be the acknowledgement that will be that should be received by the window size time. So with respect to the number of frames that is being sent in the window size, that is there. So this is the frame number 1 sent, and acknowledgement is while receiving it is not received. So next is here. Next there is a request for next frame. So next frame is sent. 2 is frame sent, and next frame to be sent is 3. This is SN and SF that you need to take care. So frame 2 is sent, and then with respect to frame 2, the acknowledgement, because it has received the frames. So this receiver is receiving the frame. That's why it is generating the acknowledgement with respect to that and keep on increasing the acknowledgement number. So here the acknowledgement is 3. So acknowledgement 3 is sent, and it is now waiting for the acknowledgement number 3. So frame number 3 is sent, and then it will be sending the acknowledgement 4. Okay, that means it is waiting for acknowledgement number 4. So in between you can just see here. So when in go back and ARQ, basically what is there? Suppose acknowledgement 2 is lost. So this is one of the case, like if the acknowledgement 2 is lost, and it is after that it is sending the acknowledgement number 3. Okay, so acknowledgement number 2 means the acknowledgement for frame number 1 is lost. Acknowledgement for frame number 2 is sent. That means its meaning is like it has received the frame number 1. So here up to here you can just see up to here it is waiting for acknowledgement number 1, 2 and 3. But after receiving the acknowledgement number 3, its meaning is this acknowledgement number 3 will be having like acknowledgement for 1 and 2 also. So then 1 and 2 will be white. Now the window will be shifted to here. So this is the basic idea into the go back and ARQ that is given in this case. Some examples are given. You can just go through these examples and you can find this algorithm more its analysis. You can just go through it. Okay. So the next point is stop and wait ARQ is a special case of go back and ARQ in which the size of send window is 1. So it is going to say like stop and wait ARQ is similar to the go back and ARQ, but instead of sending more number of frames into the go back and ARQ, if go back and ARQ is having a window size of 1, then the go back and ARQ will be behaving like a stop and wait ARQ itself. This is the basic point that is mentioned here. So that's why stop and wait ARQ will be the special case of go back and ARQ.